All right, so previously we talked about function notation, and now we're going to talk about how to apply that to a composition when we're given a graph. So algebraically we saw the composition of functions, and now we're going to take a look at how this is when you're dealing with graphs. Okay, so just like before, this says f of g of 0. So here we're going to start with the inside. 0 is closest to g, so we're going to do g of 0. Now do be careful, this is f of x, and this is g of x, so you do have to know that. So I'm going to circle it so we're aware that this is f of x, and this is g of x. So when I do g of 0, I don't use this graph, I use the one that has g. So g of 0 is right here. That's my x value, so I'm going to try to find my y value. If I go down, it doesn't touch the graph, but if I go up, it hits the graph right there at positive 2. So in this case, I know that g of 0 is 2. So now, instead of writing f of g of 0, I can write this as f of 2. Okay, because g of 0 we now know is 2, so now I'm looking for f of 2. Since this has an f, I look at the first graph. So I go to x is 2, and at that point there I can see that's the only part of the graph it hits, and that value for y is going to be 0. So my solution is that f of g of 0 is 0. All right, for the second one, g of f of 1. Once again, the 1 is in the inside, so we work our way out, so f of 1. Since I see f first, I go to the f graph. So f of 1, x is 1. I go down, I don't hit the graph, but I go up, I hit right here, and I can see the y value is 3. So f of 1 is equal to 3. So when I go back to this original one, instead of g of f of 1, I write g of 3. Since this has a g, I go to the g graph. X is 3, so 1, 2, 3. I see it hits the graph right there, and that y value is 1. So my solution for g of f of 1 is 1. Now for f of g of x equals 3, what you should notice is that this is x and this is y. So this is taking the place of y here now. So it's asking us to find the corresponding x value. So here it's a little bit different, so be careful here. So I'm going to start from the outside, right? If it was in the inside, I worked my way out. If it's on the outside, I'm going to work my way in. So instead of saying f of g of x equals 3, what I'm going to say is that f of x is equal to 3. So I go to the f graph, and I go to y is 3. So y is 3 right here. Now I'm going to draw a line just so I can start seeing this now. And what you should notice is that it actually hits the graph at 2 x values. The first x value hits is at 1. And the second x value hits is at 5. So what this means is I have 2 answers so far that could become many answers. Okay, so now this isn't actually x, this is g of x. So now I'm going to set each one of these values equal to g of x. So now we have that g of x is equal to 1 and g of x is equal to 5. Okay, so now we go to the g graph, and we're going to I draw a horizontal line to see where it hits. So g of x equals 1. So the y value is 1. I'm going to draw a horizontal line, and I'm going to circle where they intersect. I see it intersects 1, 2, 3 times. For g of x equals 5, I go to y is 5. I draw a line. And what you notice is it doesn't hit any of the graphs, so this has no solutions here. But that first one, g of x equals 1, actually has 3 solutions. In this case, x equals, the first one is -1 for x. The second one is +1 for x. And the third one is 3. So that one had 3 solutions. X is equal to -1, 1, and +3.